Okay, welcome to exercise 1D, solving linear equations. In this exercise, our learning intentions will be solving linear equations and also solving solving equations involving algebraic fractions. So it does get a little bit complicated at that stage. There is a lot of pre-learning questions, even though there's only 2 examples. One of them is question 15, okay? So make sure you get right and have a go at that one. For all of these, left-hand column, bottom row is enough, okay? So please make sure you do that pre-learning. It's really important. It's going to give you a chance to really excel in this class because we'll be able to do some better stuff in class, or if it was really tough, get some extra help, okay? So the key ideas in this is you're going to be given an equation and you'll be able to figure out what the value of the pronumeral is. This, with the left-hand side equaling the right-hand side, we will be able to substitute back in at the end, whatever result we come with, and you'll be able to check, okay? So the definition of a linear equation is one that has pronumerals with no power higher than 1, okay? That also includes no square roots and things like that. Useful steps are using inverse operations, i.e. backtracking, collecting like terms, expanding brackets, and multiplying by the lowest common denominator. Backtracking involves inverses, okay? It's inverse operation. When I was talking about the identity inverse, you'll see why, okay? So linear equations don't have roots, squares, or cubes, just pronumerals to the power of 1. In this exercise, you'll be using many of the skills already taught in this unit. So hopefully you've done your hard work already up to this point. If you're not already confident with identity inverse, you won't be able to backtrack, okay? So you need, how do I get rid of an addition? Well, I subtract the same thing that's added. How do I get rid of a multiplication? I do a division, etc., etc. Okay. You need to be able to expand and collect like terms, otherwise you won't be able to simplify. That's also really important. Okay. So if you have any doubts on any of these topics or concepts that I'm speaking of, you know where they are earlier in chapter 1. Go back and practice. Okay. Always remember to substitute the value back in to the equation at the start. Then we can check if the right-hand side is equal to the left-hand side. Okay, they need to be exactly equal. All right, so once again, here are the videos. Let me make this a bit bigger so it stands out more. So you can watch this video here, the one that I'm moving. To do these questions here. This is my attempt at it. For some of them I've used some colors to make it clear what I have done. Of course, you don't necessarily have to write out this second line here. You might go straight to the second line, okay? Quite often what you see in blue you can skip. All right, so in the end I've come down and I've figured out that x is equal to 3. So if I'm going to check that, I know what my right-hand side is 17. I don't want red. I want this white. So left-hand side equals 4 times 3. Okay, x is equal to 3 plus 5 equals 12 plus 5 equals 17, which equals the right-hand side, okay? So my left-hand side equals my right-hand side, so I have to be correct. Pretty happy with that. All right, so I had it written here in brackets, so I had to expand these brackets. And then I started doing my inverse operations. So I subtracted 4x from both sides, and then I subtracted 15 from both sides. And then I divided by 2. All right, so now I've got this x is equal to minus 15 on 2. So let's check, okay? So my left-hand side is equal to 3 times 2 times x, so 2 times minus 15 on 2 plus 5 equals 3 times, inside the brackets, 2 times something divided by 2 just makes it itself, minus 15 plus 5 becomes minus 10 equals minus 30. All right, and my right hand side equals 4 times minus 15 on 2. So the 2 and the 4 cancel to become 2 equals 2 times minus 15 equals minus 30. Yes, right hand side equals left hand side. Pretty pumped. Okay, so that was fairly, hopefully, straightforward for you guys. This is level 10A maths. Example 2 is now we're starting to use some fractions here, okay? So solving them will quite often involve some multiplication to get rid of our denominator. So in this case it was straightforward, it was just a 4. I've multiplied both sides by 4, subtracted the 3 away, x equals 5. So what does my left hand side equal? Let's double check that. So 5 plus 3 divided by 4 equals 8 on 4 equals 2. So that equals my right hand side. So I am just totally psyched. Right, okay. So for this one, this is another step up, okay, because we've got a fraction on both sides. So I multiply this side by 3, which means I multiply the other side by 3. So I've got to multiply the whole expression on the numerator. So I brought out the power of the brackets and did the same with the 2. Then I've expanded the brackets. Okay, and now I've just got my pronumerals, x, times some numbers, and I've got some other constants just there. So I made the choice of subtracting 8x away, so that way I've got a positive value of x. I've got a minus here, so the opposite of minus is plus, isn't it? Okay, my inverse thing. So minus 4 plus 3 is minus 1. So if x equals minus 1, this left hand side will equal 2 times 4 times minus 1 minus 2 equals 2 times minus 4 minus 2 is minus 6 equals minus 12. And my right hand side will equal 3x minus 1 on 2. So 3x, so 3 times minus 1. I made a mistake here. Which one did I do? Oh, silly me. All right, let's go back, get rid of that. What a duffer. Okay, left hand side is 4x minus 2 on 3. Okay, so 4x, so 4 times minus 1 minus 2 divided by 3. And we did that earlier, so I know that that's minus 4 minus 2 is minus 6 on 3 equals minus 2. And my right hand side is equal to 3x minus 1 on 2. So 3 times minus 1, was it right? Minus 1, all divided by 2, equals, so it's minus 3 minus 1, so minus 4 on 2 equals minus 2. Ka-ching! That was very good. And here we go. So now we've got the fractions on the same side. So I have to know how to do my algebraic fractions, right? And so hopefully you're more confident after the last exercise. You can straight away see that I've just put them on 6 straight away. And multiplied both sides by 6, expanded the brackets, collected all the like terms, got numbers on one side, prime numeral on the other, and then did the division, and now x is equal to minus 17 on 4. Well, this check, let's have a look. Minus 17 on 4, so we got x minus 2, minus 17 on 4, x minus 2, all divided by 3. And it's a minus 2 times minus 17 on 4. Take away 1 on, excuse me, 3. Oh no, that 3 is already there. And is that it? Okay, so what is this equal to? So this is my left, I should wrote left hand side is equal to this. And so I've got 17 on 4 there. If I multiply the other side by that becomes minus 17 minus, so I multiply this by 4 to make it 8, all on 4, and all of that is divided by 3 minus, how much room have I got here? I've got endless room. And also, if I do the multiply this by 2, that makes this become 2, so it becomes minus 17 minus 2 on 2, all divided by 2. All right, and so now we have got minus 17 minus 8, is that right? Minus 17 minus 8 is, so I've got minus 25 on 4, all divided by 3, minus 19 on 2, all divided by 2. And I'm going to multiply this one by 2. And the right one by 3. So I'm going to say minus 50 on 4. Oh, and be a minus here. Minus 30 plus 27 minus 57 on 2. All divided by 6. Okay. So I've got to make these fractions the same now, and so I've got to multiply this one by 2 to make it 4, so that equals minus 50 on 4 still, minus a minus gives me a plus, 114 on 4, all divided by 6. So 114 divided by, might take away 50, so that's going to equal 64 on 4, all divided by 6. What's 60? 8 eighths are 64. So I've made a mistake somewhere. What do I need to equal? I need to equal 4. That can't be right. What have I done? I'm going to leave this as a mistake and we'll check it in class. And I'm going to pause the video and I might try and fix it on my own. Okay, back again. I did fix it up. I made a mistake. There's a quick thing. I'm going to get rid of it. So you can fix it up. All right. So I will leave it like that. So you guys can fix it up properly before class. Okay. All right, so I'll see you in class. Make sure you get that pre-learning done as usual. And yeah, have fun, party on, and be nice to your family.